So I'm still working on this thing, and I made interesting discovery. As a last resort, I swapped, turn it on, swapped the two boards over. A lot of hassle, a lot of wiring, but now I'm on the right channel with the scope, and that was the clean channel before, and now it's got the noise on it. And the left channel was dirty before. Go on the left channel, that's virtually quiet. So it appears that this board has something about it which makes it behave in a different matter. And I've just seen something green there, a bit of corrosion. I doubt that would be it. Yeah, C6, got a bit of corrosion around it. What does C6 do then? When can I find C6? I can't see C6. It's a little one. Maybe it's C4. No, definitely C6. C6, 27 PF. Where was I? Yeah, down there. 27 PF C6. And also C5's a 27. I wonder if that could have some influence on it. But it's dragging the bloody board out again. At least I don't have to take all the wires off it this time. So let's do that, drag that out and put a new capacitor in there. Yeah, so I replaced it with a 33 because I didn't have a 27. So let's try now. No, didn't make a slight difference, didn't really think it would do, but it just shows you there may be other issues on this board. I'll have to look into it. Well, I think I'm making some progress now. It's quite bizarre. I mean, I've checked every resistor and capacitor, they're all fine, but I was checking the bias by disconnecting the positive there and sticking my meter in a series, and it should be 100 milliamps. It was 140, so I tweaked it down to 100, and of course I had loads of wiring in series with that red wire, and the noise went away completely, which is bizarre. Well, not completely, but 99% of it went away. So it seems adding that extra bit of wiring actually affected it, but which led me on to the decoupling, which I've put in on that side of that 10 ohm resistor. Where is it? 10 ohm resistor. If I remove that decoupling capacitor on the positive rail, the noise goes away, which is very strange. So let's have another look on the screen. Turn it on. Right. Now that is what used to be the bad channel, and the good channel, that's the good channel, and that's with that decoupling capacitor removed, which is quite bizarre, but it seems to work, which is strange. So I'm just going to try another identical capacitor in that position. I fear noise will come back again. Okay, New capacitor installed. Let's try again. Quiet. That's really bizarre. Oh, I'm on the wrong channel, I think. No, on the right channel. Both channels. No noise. And that is quite bizarre, because I measured that decoupling capacitor. It had a low ESR and it had the right value, about 980 microfarads. But that seems to have completely cured it. So that is unbelievably weird. So I just got to tidy all this mess up and get it all back together. Well, that was fun. I was soldering that red wire back on, and as soon as I touched my soldering iron onto the red wire, I had a massive flash, and of course I'd forgotten to turn off the power, so I had plus 50 in theory going through my soldering iron back to earth somehow. So, but it all survived. Shook me up a bit there. Anyway, new capacitor's installed, and it works, of course, because I just tried it before. So I've just got to put some more heatsink grease on there, bolt it back in there, and do some final tests on it. Right, all back together, and look at the screen, and that's essentially noise free. A few odd spikes, but we are down at 500 microvolts per division. Go up to the audio analyzer, and it's struggling to read that. It's below 0.1 millivolts, and it can't get a frequency reading on that. So that looks good to me. And try the other channel, which was the good channel. That's slightly higher, but very low anyway. But I think it's all good. But I might do a signal to noise ratio using the 8903. So I'm going to do a signal to noise ratio, and I've set the output from the 8903 to give me maximum power, which is 89 watts, before clipping. So now how do I do this? Signal to noise. Okay, what it does is it applies a signal at maximum power, does a measurement, turns the signal off, measures the noise, works out a computation, and that's the result you get. 89 to 90 dB, which is, I think, good enough for me. So enough of that. Just turn it off, I think. But it was amazing, wasn't it? But changing a capacitor could make that much difference to the noise on that channel. And I think the only thing now to do with it is to take it back in the lounge and see if I can still hear any hum. If I hear hum now, I think it's going to go through the window, the amplifier I mean. Here we are back in the lounge yet again, getting fed up with carrying this thing around. Now, as far as I can hear, that is totally silent. Totally silent. Other speaker. No, not a trace of anything. So that's about it. I think I've cured it. I think I'll have to check this other board for bias, because as I said, this one's a bit high at 140 milliamps. It should be 100 milliamps. And a bit of music maybe, if there was anything worth listening to.
And before that, Casey JPS.
No, nothing worth listening to. So there we go then. End of yet another too long video. Bye for now.